Bulbasaur. Let's get ready for today's lesson. You want to pick out some chalk? Hello trainers, Nurse Joy here. Welcome to the Pokémon Center Online Community. Today's video presentation will be an anatomy and physiology lesson about Bulbasaur and its evolutionary line. I've chosen Bulbasaur because that is my companion Pokémon, but also because these are the first few Pokémon listed in the National Pokédex, so it seemed like a logical place to start. Today I will be aided by the text Pokénatomy by Professor Christopher Stoll. Now, this is both a fundamental yet controversial publication within the Pokémon science community. If you are unfamiliar, Professor Christopher Stoll is known for this thorough publication of the anatomy and physiology of Pokémon, yet the controversy lies in some of his otherworldly observations. Sometimes he refers to things that do not exist. It is rumored that he is an interdimensional traveler. That all being said, this publication is thorough and detailed and has amazing illustrations, making it a cornerstone of learning in the Pokémon science community. Alright trainers, on to the lesson. Okay trainers, we will be using this view for some of the lessons so you can appreciate the beauty of this very significant scientific work. So here's a nice view of the cover, and again, the text that we will be utilizing for this lesson is Pokénatomy by Professor Christopher Stoll. It has quite a beautiful cover with Pikachu, front and center. Nice internal view of his skeleton there. And then around this circle, we have some other friends. And the Pokemon of focus today, Bulbasaur, is featured right here on the cover. We also have some Pokeballs on the border, like the real one I have there. Alright, let's go ahead and open up this text. So here on the title page, you can see all the professors that are credited in contributing to this work. And the introduction over here is one of the main sources of the skepticism and controversy surrounding Professor Christopher Stoll. Let's just read it and see what you think. Introduction. This book's contents is based upon real animal anatomy, behavioral biology, and scientific principles. However, it is intended primarily to entertain and inspire. Many of these Pokémon are only vague approximations of real organisms. Some bear combinations of traits that do not occur anywhere in the natural world, and a few have abilities that strain the possibilities of our scientific understanding. It is the duty of the book's bearer to question and to explore, to use these incredible monsters as a lens through which to appreciate the beauty, complexity, and uniqueness of real organisms. The world is full of nameless things and mysteries yet unanswered. Go now and learn all that you can. So, a very beautiful sentiment there, but like I was talking about, phrases like animal, that does not exist. I guess it's another word for Pokemon, yes. I don't really know what he means by real animal, though. But overall, the purpose is to learn about our natural world and the amazing Pokemon that are a part of it. Something I am very passionate about, and that's why I connect with the work of this professor. Okay. So the index here, we will be using pages 1 through 5, Bulbasaur, Ivysaur, and Venusaur. So if you have a copy of this text, you may follow along at home. And as you can see, only the first 151 Pokemon in the Pokedex are represented. That is because Professor Stoll is from the Kanto region, and he worked as a graduate research assistant under Professor Oak. So, the region's Pokemon are the focus of Professor Stoll's research and subsequent publications like this one. Okay. There's a little section on eggs that we won't really be covering today, but I do want to stop on this illustrated page to look at figure number 12, because this is Bulbasaur's egg. And since we'll be talking about Bulbasaur and its evolutions today, it's good to start at the very beginning of the life cycle with this egg. You can see that it's a green egg covered in a leaf-like material that is reminiscent of Bulbasaur's bulb and Ivysaur's flower and so on. Okay. Little explanation about evolution. That again will not be the focus today. The focus of today's lesson will be the relationship between Bulbasaur and its bulb, and the surrounding hypotheses on the topic. We will also be taking a look at the anatomical evolution between plant and Pokemon. Alright, so on page 1, here is Bulbasaur. As you can see here, there is a seed core present inside of the bulb, and it has these tendrils that come down throughout the body and attach itself to Bulbasaur's spine and rib cage. And at this stage, the tendrils also grow in parallel to the host musculature. A very interesting anatomical feature of Bulbasaur is how it mimics plant life through its bulb. And truly, the bulb part of Bulbasaur is a plant in some sense, but it works with the organism to become more Pokemon. But the feature I'd like to focus on is Bulbasaur's ability to use photosynthesis through its bulb. So as you can see illustrated here, there are several different layers of Bulbasaur's bulb, and one is a photosynthetic layer that helps use sun energy into life energy, into food. The true nature of the relationship between Bulbasaur and its bulb is highly disputed when it comes to labeling it as a symbiotic versus parasitic relationship. The position presented here by Professor Stoll is that the relationship begins symbiotically as long as the Pokemon remains a Bulbasaur, but then develops into a more parasitic relationship during evolution as Ivysaur and Venusaur. So let's take a look at what the text has to say on Bulbasaur's page. Physiology. At the core of Bulbasaur's symbiosis is a seed-like node that grows with its host organism. Though non-sentient, this node is tied directly into the host nervous system and can process sensory data, functioning as a secondary neural ganglia, like the small secondary brain in Onyx and other large Pokemon. This node allows Bulbasaur to coordinate efficiently while on the move. Without the plant's additional mental capacity, Bulbasaur would be unable to control its powerful vines in combat. So, trainers, a great thing about learning your Pokemon's anatomy is understanding how it utilizes its moves in Pokemon battle. Because if you understand how the Pokemon's body functions and how it is able to use its powerful moves, then you will be able to keep your Pokemon in peak health and, monitor it for certain illnesses, ailments, problem, and so on and so forth. Of course, Nurse Joys are all over the country here for that very purpose as well. But if you can identify the problem more readily, the less severe that the prognosis, might be if you catch something early. Okay, let's read on. The symbiotic plant-like creature housed on Bulbasaur's back extends tendrils that interlink the nervous and circulatory systems of two organisms. The heart of an adult Bulbasaur is bound by tuberous growths, feeding blood to the bulb on its back. So, Professor Stoll's perspective is that Bulbasaur's bulb is an independent organism in its own right. However, the two are fused together, sustaining life on both ends. Alright, so again, just an overview of what I want to highlight here, trainers, is that Bulbasaur's relationship with its bulb is a symbiotic one when it starts in this stage, and that the bulb is a main source of Bulbasaur's very powerful moves like Vine Whip. So, as you most likely are aware, when Bulbasaur evolves, it becomes Ivysaur. And this is where Professor Stoll's perspective, hypothesis on this matter, and my own begin to differ, but we will discuss that. Let's first look at the anatomy. So here we have a Ivysaur, slightly larger in size than Bulbasaur, and as you can see, the bulb has begun to bloom, the petals have opened, and a muscular flower has revealed itself. Internally, the seed core is still present, but the plant tendrils have began to invade Ivysaur's nervous system, both its central and peripheral nervous system. So the Bulbasaur's relationship with the plant tendrils is on a muscular level, but this becomes more into the nervous system at this evolutional stage. So you can see how it goes throughout the body. And the bloomed. Let's read what Professor Stoll has written here under Physiology. The bulb cannot complete its life cycle without a host, and because of this, it is advantageous for the symbiotic bulb to preserve Ivysaur's health. This is unlike Paris, where the host's death is necessary for reproduction. Because of their dual nature, Ivysaur are quite adaptable and can endure a variety of extreme environmental conditions neither organism could survive alone, speaking of the bulb and the Pokemon. In harsh desert climates, the bulb can sustain its vulnerable host with energy from the sun via photosynthesis and by trapping dew on its hydrophilic petals. So, what is stated here has been widely known that Bulbasaur, Ivysaur, and Venusaur can all utilize its bulb or flower to photosynthesize energy or food. But the unique perspective that is a now developing school of thought that Professor Stoll presents here is how this is more of the independent organism. The bulb is in control of the Pokemon. So, as you see here, Ivysaur's bulb flowers during evolution, growing fleshy petals in a tightly bound bud. These will fully expand only once the Pokemon has matured into its final form, aka Venusaur. During this phase of the Pokemon's life, the plant begins to more deeply integrate itself, assuming near total control of Ivysaur's central and peripheral nervous system, suppressing the host's ability to control its own body. It is difficult to prove if the presence of plant tendrils in the nervous system truly suppresses the Pokemon's bodily control. There are two schools of thought here. One, that Ivysaur is the dominant portion of the partnership, using the flower to sustain itself more effectively with photosynthetic energy, what has been widely accepted in the scientific community thus far, versus the one supported here, that the bulb is truly in control. Now, like I said, I am in the camp that Ivysaur maintains body in my control, therefore deeming the relationship between bulb and Pokemon to be symbiotic, while Professor Stoll maintains that the relationship is a parasitic one, or becomes a parasitic one when the Pokemon evolves into Ivysaur, and the Pokemon becomes a puppet for the plant. I'm presenting this text despite our hypotheses on the true nature of Bulbasaur's relationship with Bulbasaur and its evolution's relationship with its bulb, to give a well-rounded perspective on this school of thought. Because the thing about science, you must present all arguments to be able to give a comprehensive thought about your own perspective. Now, my argument, and those within the scientific community that believe that the Pokemon is in control and the relationship remains symbiotic, is that the bulb's integration into the central and peripheral nervous systems allow for sensory information to be relayed more effectively. So basically, it attaches itself to the peripheral and central nervous system as a way for sensory information to be processed better by Ivysaur, so he can feel what is going on with the bulb much more effectively than Bulbasaur can. Lastly, we will discuss Venusaur and how the relation develops in the final evolution of this evolutionary line. As you can see, the flower completely blooms and the Pokemon becomes significantly larger in size versus the earlier evolutions of Bulbasaur and Ivysaur. On the anatomical level, the plant tendrils are present throughout Venusaur's entire body, unlike solely in the nervous system in the prior evolutionary stage. So it has taken over the brain, all body parts. Every body system is integrated with the flower's root system, as you could say, or plant tendrils. So Professor Stoll notes here, although the bulb and host are deeply intertwined, the two organisms cannot fully integrate at the cellular level. The bulb's plant cells produce and store energy differently than the host. Even at this late stage of development, Venusaur are still two mutually dependent organisms. The plant cells in the bulb must be partitioned by a series of adaptive organisms and complex biochemical exchanges in order to interact with the host cells. So basically what they're saying here is that on the cellular level, there is a clear division between Pokemon and plant, despite the presence of both cells being throughout the body, and that many unique cellular exchanges are present in Venusaur to function. So, again, Professor Stoll continues to elaborate on how this is a parasitic relationship for the Pokemon by stating the noted presence of plant tendrils in the brain causes a total loss of the Pokemon's will, leading to notably sedentary lifestyle comparatively to Bulbasaur and Ivysaur. Now, Venusaur's sedentary lifestyle is an observable trait versus its evolutionary counterparts of Bulbasaur and Ivysaur. However, this can be noted to other environmental factors such as size, weight, and age. Venusaur is much larger than Bulbasaur and Ivysaur. And something we see here often at the Pokémon Center is osteoarthritis present within Venusaur, or wear and tear arthritis, when the cartilage between the bones wears down due to age, weight, and size. So this makes movement much more difficult and painful for Venusaurs, therefore leading to more sedentary lifestyle. Also, a decrease in mobility and balance could be present due to age, and this is seen in many other organisms' life cycle, including humans. As we age, we slow down, become more sedentary. So, that observable trait isn't necessarily a sign that the Pokemon has lost its will to the bulb. It could just be other environmental factors. I think that is where the divide in the community between the symbiotic and parasitic relationship hypothesis is drawn, versus those like Professor Stoll who are looking at the anatomical structures and drawing conclusions, versus those like myself who are also with these Pokemon constantly and see the more lifelike, in-your-face, medical side of things. And I believe that the true answer is probably somewhere in the gray area between the two hard definitions of symbiotic versus parasitic relationships. The question to answer is, does Bulbasaur and its evolutionary line sustain harm from the plant tendrils within the body? That conclusion is dependent on how the integration of the plant within the Pokemon affects its sentience. We can see on a physiology from a physiological perspective that the plant helps the Pokemon by giving it extra energy, especially at this stage where the Pokemon is so large and requires so much energy, and Venusaur keeps its flower alive. But the perspective here is the opposite, that the flower is controlling Venusaur. But again, I think it is more likely just being in the presence of Venusaurs that they are sentient, and the flower merely enhances their ability to be a great companion for you and a powerful Pokemon. And their sedentary lifestyle is more due to the natural wear and tear of Pokemon, such as osteoarthritis. Trainers, you may be wondering, Nurse Joy, I'm not a Pokemon professor. Why do I need to know this complicated anatomy and physiology of my Pokemon? Well, I'm glad you asked. Knowing your Pokemon's anatomy and physiology can be very beneficial to you as a Pokemon trainer. For starters, it can help you identify injuries sooner in your Pokemon, as well as keep them healthy preventatively. It can also help you strategize in battle by knowing how, energy expending each move is on your Pokemon, and extending the longevity of their career as a Pokemon that battles. So, I urge you to learn more about the science behind Pokemon battle, and that will make you a better Pokemon trainer. Another thing to be aware of, again, when you are evolving your Pokemon into these very, very large individuals. Many people keep their Bulbasaur as Bulbasaur for this reason, because Venusaurs do have so much muscular skeletal problems, joint issues, arthritis, so on and so forth. And that is why I'm so passionate about educating all you trainers out there, so you just know just a little bit about each of your Pokemon, and making a decision to evolve them is a very big thing. Again, of course, Pokemon are always capable of spontaneously evolving, so they can also make that choice for themselves. But in these days, I feel like the trainers are often the ones deciding this, so just something to keep in mind. But if you're interested in scientific hypotheses just for the discussion aspect, I do urge you to become a Pokemon professor. Your unique perspective and Pokemon relationships that you build as a Pokemon trainer is a very valuable perspective in the Pokemon science community. Thank you so much for joining me for this video presentation today. I hope you learned something. See you next time.